Okay, welcome back. This video I want to explain how to calculate work when you're pulling a rope, especially in this case I'm going to be pulling a rope over the edge of a building. That seems to be a common example used in calculus 2. It's relatively simple, but it's you just have to understand the process in order to make it work. So let me try to explain exactly what I'm talking about. So let's say you have a building and the building is a certain height, let's just say 200 feet high. Okay, and let's say you have a worker at the top of the building and they're pulling a rope that's dangling off over the edge. Let's say the rope is, let's say 100 feet. And so as you're pulling the rope over up to the top of the building, because you have some of the rope sitting at the top of the building, after you start pulling, the force that you need to pull the rope becomes lower and lower as you go, as you pull more and more of the rope. So it's remembering that work equals force times distance. So the original distance, you just have to set up the problem correctly. The force is going to be reducing as you pull more and more of the rope over the edge. So the way I like to do these types of problems is you have your y-axis and your x-axis, and this guy is going to be distance here, and then this guy is going to be force here along the y-axis. So force is going to be a function of distance. So these types of problems, okay, so a couple things we need to know. The length of the rope that we're pulling over the edge. If they could do something clever, like if this distance of the rope was actually made so that the rope was coming down and coiling on the ground and you're pulling it up, then the force would be equal for a certain amount of time, and you'd have something that looked like this, and then it would start to come down linearly. But let's just act like the rope is actually shorter than the building, so which means no rope is sitting on the ground. So that means you're starting off at some initial force. So sometimes they say that the rope actually equals like 50 pounds. That's one way to do it. In which case you need to know how many pounds over how many feet. And that really becomes your slope of your force right here, because this is feet. Right here is your distance, and then how much force is reduced per unit here is actually a nice linear slope. So in this case, 50 pounds of rope for 100 feet, so it would be change in y over change in x. So change in dy dx would equal 50 pounds per 100 feet, 0.5. Okay, pounds per foot. So sometimes they give you that directly in the problem too. Instead of giving you a total mass of the rope, they'll just give you how many pounds per foot it is, or how many kilograms per meter it is, or something like that. If it is in kilograms, remember you have to convert it to a force by multiplying by the acceleration of gravity. But in this case, we're already in pounds. Okay, so the way I'm thinking about it now is I want the profile for force and distance. If I think about distance of how much rope I've already pulled on top of the roof, rather than distance like this here, that means that if I've pulled no rope on top of the roof, then I'm holding all of the force of this rope, which means, as we said, 50 pounds is right here. So at 0 distance, I've got 50 pounds of rope. Okay, and then at 100 feet, I've got 0 pounds of rope left. So I have a nice straight line from 50 pounds here to 0 pounds at 100 feet, the distance of the rope. Okay, so that is just a simple linear equation of a line. So remember, y equals mx plus b. Well, b is 50. And then my slope, since it's negative, is negative 0.5 x. So instead of y, I'll say that's my f of x equals negative 0.5 x plus 50. Okay, so if you remember, how do you calculate work when you have a varying force? It's going to be the integral from b to a, that function for force, dx. Okay, so work, my marker's making noise, is going to be the integral. We're going to say we're going to pull the whole rope over the board, over the edge here. 100, it's 0, fix my w, and then we just have negative 0.5 x plus 50 dx. Hope that's clear. So we just have to take the integral of that, and if you remember, we move over just a little bit here to give me a little bit of space. Work equals, I'm just going to do this integral, so I'm going to have negative 0.5 x squared divided by 2 here, plus 50x, and that has to be solved over the range 100, 0. So really, when I plug in the zeros, that's going to go cancel out. So really, it's going to be negative 0.5 over 2 times 100 squared plus 50 times 100, and that'll give us a nice number. So I can carry it out, or you guys can just solve it from there. Hopefully that explains it. You just have to look at the initial conditions. What's the rope doing? How long is the rope? How do you calculate? How do you make this type of function here? How do you translate what they're telling you into a force per distance? Okay. I think that's all I want to say on this. I'm trying to remember if there's any other challenging things they'll do for you for this. Anyway, if I think of something else, I'll post another video or correct this one. So anyway, good luck, subscribe to the channel, and have fun.